Okay, let's unpack this. Have you ever wondered how cutting-edge technology isn't just helping creativity, but actually fundamentally redefining it? Today, we're taking a deep dive into this really fascinating university course called Data in Design. It's all about building, well, a powerful bridge between that intuitive human design sense and the huge capabilities of computational power.
Yeah, and what's truly fascinating, I think, is how this course tries to tackle a really fundamental question. How do we actually translate that often intuitive design process into a language computers can understand and, work with? Essentially, how do we codify design using computational methods? We'll explore the unique mix of knowledge you need for that and the journey the students went on.
Okay, so we've got some great source material here. We have the full course summary, a video overview looking back at the semester, and a couple of briefing documents, too. It feels like getting a cheat sheet almost for a whole semester of advanced learning, just distilled down for you.
Exactly. And if we connect this to the bigger picture, the whole philosophy driving this is about cultivating what they call a design science engineering perspective. It's not just about learning a new piece of software, right? This
Yeah.
is about fundamentally rethinking design through a computational lens,
Mm.
bridging that gap people sometimes see between, artistic vision and algorithmic precision.
Right.
Imagine instead of just drawing a building, you build an algorithm that can design thousands of variations, test them structurally, optimize for energy, all before anything's built.
Wow.
That's the core idea. It lets designers become architects of intelligent systems, not just static shapes. Now, doing that, of course, means students have to combine deep design knowledge with, well, computer science and numerical analysis.
That sounds incredibly powerful, and it makes total sense from a computational view. But thinking about it from maybe a more traditional artistic or intuitive design standpoint, does bringing in all this data, all this algorithmic precision, does it ever risk maybe stifling creativity? Or is it always seen as an enhancement? And how did the course actually start this journey? How did they begin transforming design with data?
That's a really good question. And it's something the course addresses, I think, implicitly by empowering designers, not replacing them. It gives them more tools,
Hmm.
allows them to explore a much, much wider range of possibilities.
Okay.
And the how? Well, it was through an incredibly structured approach. Picture this. Course was built from 17 distinct sections, and these were curated from over 100 existing computational design modules, covering everything parametric coding, vector, raster, 3D viz, the works.
Wow, 17 sections, over 100 modules. This is a deep dive right there. So where did they even start with something that massive?
Yeah, they started with the absolute fundamentals. So weeks 1 and 2, they focused on understanding that core relationship between data and design. Then dived right into foundational coding principles, things like data structures, programming methodologies. Think of it like learning the alphabet and grammar, sort of, for computational design.
Got it. Learning the language first. So once they had that foundational language, how did they start applying it visually? Because design is so visual,
Yeah,
right?
exactly. That came next. Things got visual and really practical. Weeks 3 through 5 moved into studying vectors and geometry in depth points, lines, curves, surfaces. And crucially for designers, how to use object-oriented programming, OOP.
OOP, right.
Think of OOP like building with digital Legos. You create these self-contained objects, maybe a door or a wall, and each has its own properties and behaviors. For design, this means you can translate complex design elements directly into code that's modular, reusable, and actually much closer to how you might intuitively think about putting a design together. It's a real shift from just drawing to, well, programming systems.
That Lego analogy really helps bring it home.
Yeah, you're not just drawing lines, you're defining these intelligent bits. So, okay, they've got these foundational building blocks. The logical next question for students must have been, how do we use this for really complex design challenges?
Precisely. And that's where the course went next, into more advanced concepts, like discretization, which sounds technical, but it's a profound shift in approach. You break down continuous forms into discrete units, like pixels or voxels.
Right, like tiny building blocks.
Exactly. And doing that lets designers computationally analyze, optimize, even generate designs with a precision and scale that, well, traditional methods just can't match. It turns an intuitive sketch into something rigorously quantifiable, something iterative. They also looked at structuring designs using meshes and graphs, which is vital for things like network analysis, pathfinding, optimizing flows within a design.
And I'm guessing AI starts to play a pretty big role around here. Oh, absolutely. Critically, they delved into AI and data,
Uh-huh.
covered data-driven design process codification,
Hmm.
using regression analysis, analytical models, and these really powerful generative models. So, yeah, this isn't just about making pretty pictures anymore. It's about creating intelligent design systems.
Okay.
And they explore different ways to solve problems algorithmically. You know, precise deterministic algorithms, good for optimization, stochastic algorithms, which bring in a bit of randomness, great for exploring wider, more creative options. And even brute force methods, just systematically trying everything. Each gives you a different lens on the design problem. They even covered dynamics and agent systems like particle systems for sophisticated data collection and packaging and complex simulations.
Okay, so it's one thing to generate these incredibly complex data-driven designs computationally, but what about the human side? How do designers actually see this flood of data? How do they interpret it? And just as important, how do they share it effectively?
That's a key point. And the course's later sections really focused on that, how to visualize and deliver the design data. This covered data visualization techniques, even getting into specifics like optimizing visual clarity by eliminating light factors.
Eliminating light factors. What does that mean exactly?
It essentially means stripping away visual elements that aren't core data, like maybe complex shadows or reflections in a 3D model, just to make the underlying design data, the patterns, clearer, more discernible.
Okay, makes sense. Focus on the data itself.
Right. And they also covered advanced 3D visualization, things like camera movement strategies within these complex digital environments.
So moving beyond just the theory, the academic side, what was the ultimate practical goal for the students learning all this? Where was it leading?
Yeah, the ultimate application was really about understanding the whole pipeline for developing actual software. Full-fledged CAD computer-aided design and aid artificial intelligence-driven design software, covering everything from how you package algorithms to make them usable to creating add-ons for existing platforms.
Right.
It's about taking these abstract concepts and making them tangible, usable tools for the industry.
This whole curriculum, it just sounds incredibly thorough. What were the big sort of overarching questions driving it all for the students?
Yeah, it really revolved around a core set of guiding questions. It pushed students to think deeply about how to truly understand computational thinking and apply it to design. What different kinds of data formats can even exist in a design context? And how can we effectively codify design processes? It even challenged them to compare different approaches, like deductive versus inductive reasoning, highlighting that there isn't just one single way to solve a design problem, and introducing them to a whole toolkit of powerful frameworks and ways of thinking.
So how did students actually learn all this? It sounds like it must have involved a lot of hands-on work.
Oh, absolutely. You're right. It was a seriously hands-on approach. They had assignments weekly or bi-weekly, all building up towards a pretty rigorous final project. And for that project, students had to find real-world use cases, identify a specific design challenge where these methods could really offer a solution.
Right.
And then they had to actually structure their project's data, which means they had to define and organize all the information their algorithms would need to work with. So these assignments acted as both practical guides and, well, how they were evaluated, theory into practice.
And the resources available sound immense, too.
Oh, talk about resources. Students had access to nearly 1,900 slides, over 100 modules, something like 40 hours of YouTube lectures. Even podcast materials were provided for continuous learning.
Wow, nearly 1,900 slides, 40 hours of lectures. That really underlines the depth here. So what was the final step, the culmination of all this work?
A culmination was a final review session. And here, students got direct feedback from two really prominent experts in computational design, Professor Song-Woo Jae and Professor Kim Dong-Hee.
Getting expert feedback like that must have been invaluable.
Absolutely. And it wasn't just about presenting their work, right? It was designed to be a real dialogue. Students were encouraged to actively ask questions, seek out new ideas, even embrace the areas where maybe they didn't fully understand something yet. It really reinforces that idea that learning, especially in a field moving this fast, is an ongoing conversation. It doesn't just stop.
What a journey this deep dive has been, seriously. From getting our heads around that fundamental philosophy of design science engineering, all the way to building complex computational tools, understanding how to visualize them, apply them. This data and design course really aimed to empower designers with this transformative power of codification.
Definitely. And, the course was built around these key questions. And one that I think resonates really broadly is what data exists at the design stage and how can we explicitly or implicitly utilize it? And this leads to a crucial question, maybe for all of us listening, even beyond design itself. As technology keeps advancing, what new forms of data might be emerging in your field, whatever that is? And how could you start thinking about explicitly or even implicitly utilizing that data to transform your own processes, your own insights? food for thought.